Hi, welcome to this video about ARKAN by Malstrom. I was already editing, well, I have actually finished editing at this point, until I noticed that I hadn't shot an intro. So here I am. This video will show you a little bit of what you can do with ARKAN, which is quite a lot actually, and it's quite a long video, so let's jump straight into a bunch of patch and sound examples. After that there's a little segment where I, with a diagram, try to explain what the difference between attenuation or amplification and offsetting is. I think that's fitting to, well, include a little bit of theory in this video, because ARKAN is all about attenuation, amplification, inversion, offsetting, scaling, etc. So let's get started. I hope you enjoy the video. Before I start dissecting what the controls on ARKAN do, I want to do a little presentation about the difference between bias offset and attenuation amplification, because I think it's really important to just understand the difference. Here on the left there's a triangle, well, can be a VCO or an LFO. The shape doesn't really matter. I just chose this one because it's easy to draw. So you can see that this wave lives between 5 and -5 volts, and it is centered around 0 volt. And I first want to show you what bias offset is. A bias offset, I wrote it on the top right. Bias and offset, which are in the Eurorack world synonyms, are summation, and this can be addition plus and subtraction minus. And it's really just maths, and you can find this, for example, in precision adders or mixers. Now on the first step here, I added 5 volts of offset. What this does is it shifts the whole wave up by 5 volts. And for this wave in particular, you can see that it now lives between 10 volts and 0 volts. So we made a unipolar signal of something that was initially a bipolar signal. And I think it's clear, but it might be not. The gray line represents what the begin situation was, and the black line shows us where we ended up by adding 5 volts. Now, similarly, when we subtract 5 volts, and this is still considered bias or offset, it's just negative offset. When you subtract 5 volts, the whole wave will just shift downwards. Then for the next situation, I added 10 volts of positive offset. And again, the gray line is representative of where the wave was when we started. And then the black line shows us where we end up. So this is very similar to the previous situation, but instead of shifting the wave 5 volts upward, we're now shifting the wave 10 volts upward. And in theory, the wave would then just live between 15 volts and 5 volts, but in practice, because a Eurorack power supply only delivers voltages between 12 and -12 volts, you get something that is sometimes called running into the power rails. And I'm really not qualified to explain why that is correct. I think it's easy to intuitively see that you cannot get voltages that are over 12 volts when a system only draws between 12 volts and -12 volts of power. So that's where all Eurorack systems will clip. Some modules though, and ARKAN is no different, have built-in clipping. That's what this flattening of the wave is called. And this clipping usually happens around 10 volts and -10 volts. So now let's have a look at what I did on the bottom of this page. And this is about attenuation and amplification. And this is not summation or subtraction. Attenuation or amplification are both just multiplication. And you can multiply by a negative number. And when you multiply by -1, as we can see in the first diagram here, you just get the inverted signal. So whenever you have a module with a switch next to an input to invert the signal, this is really what it's doing. There's a built-in VCA which multiplies the signal by -1. Now in the second one at the bottom, I multiplied my original signal, which is still presented as the gray line. I multiplied this signal times 2. And this, well, it's pretty obvious what's happening here. This amplifies our signal. times 2. So whenever the signal is crossing the 0 axis, well, when you multiply 0 by 2, it's still 0. When the signal passes 2.5 volts, we multiply this by 2, we get 5 volts. And at the top of the wave there, we have 5 volt. If we multiply this by 2, we get 10 volts. So some VCAs amplify, and I'm not sure if they are called voltage controlled amplifiers, but I think they should be. And I haven't made a picture showing this, but if you attenuate a signal, it's just a multiplication by a number that's lower than 1. So I think you can imagine if we multiply a signal by 0.5, we end up with a signal that's only half as loud. The amplitude will have gone down. And it's the number of the multiplication, the amount of times a signal is multiplied. It's this number that's getting controlled when you send, for example, an envelope into the CV input of a VCA. Anyway, the third picture on the bottom there is showing us a multiplication times 3. There you can see that the signal that we end up with no longer lives between 5 volts and minus 5 volts. Well, in theory, it would live between 15 volts and minus 15 volts. And just as we are seeing in the picture above it, we get this clipping behavior at a maximum of 12 volts, or well, a minimum of minus 12 volts. Again, in ARKAN, this is set to happen before the 12 volt lines. It happens around 10 volts or minus 10 volts. And as I wrote down on the bottom there, attenuation or amplification is something that we find in 2 or 4 quadrant multipliers, which are, well, regular VCAs and ring modulators. You find this in modules, like I said, that allow you to invert a signal. You find this in, well, in some form or other in distortion or clipping modules. And this is also what you're seeing when you are attenuating a signal on a mixer, which is essentially what I meant with scaling. So with that out of the way, let's just dive into the controls of ARKAN, and I'll go over them in a methodical way, so you can see where these concepts of addition, well, summation and multiplication pop up. Let's have a somewhat methodical look at the features of ARKAN. And before opening the container with all the special ARKAN sauce, I'll just show you the controls first and the basic VCA action. The green cable here is sending a triangle VCO through data. We can see it as the top trace. I've patched this signal with the green tendril cable into the top signal input on ARKAN, and then here I'm taking the output of the top half of ARKAN again through the scope and then into my interface. And why isn't there a signal? Well, it's because this potentiometer is closed. And that's right, when there's nothing connected to the CV input here, and this is the CV input where you can patch in your envelopes, for example. When there's nothing patched in here, turning the knob clockwise closes or clamps down the VCA completely. So to get the sound to run through, we need to turn this knob to the left. So let's turn it to the left completely. That means that it's totally open and it lets through whatever is happening at the input stage. You might notice that this knob here, which is an attenuator and amplifier knob for the signal we are sending in, it's, well, at the second line. I'm not sure what time that would be, like maybe 10 o'clock. I'm bad at these things. Turning it down makes the signal more silent and closes it completely. This is like your volume knob or gain knob. And when you turn it to the right, you open up the input stage. Now, if you go past this point, you start amplifying the signal that we are sending in. And as I showed you in the previous segment, at some point this will start clipping. Now in ARKAN there's a built-in clipping circuit that causes everything to clip at 10 volts, which is perfect because you can see that when we turn up this input gain knob even more, we get these clipped edges to our wave. And this clipping or distortion is happening symmetrical. So it's the same on both sides of the wave. Now you might be wondering what you can do with a signal that is this loud, especially when you want to send it through other modules that maybe like a digital effects unit. Those might clip at these levels. Well, you can turn down the level of the output by turning this knob to the right. So the left one controls the input stage, and when nothing is connected here, the right one controls how much of that signal is going through to the output. So it's perfectly possible to get a regular 10 volt peak-to-peak signal this way. Let's open this one back up and let's turn this one to, well, kind of unity gain. You can customize the behavior of this knob. On the back of the unit you can set this to either amplify times 1, so that would mean that turning it completely to the right gives us unity gain, the thing we're seeing now. Or you can just use it like I'm doing now. And then when you turn this completely to the right, we're actually having a 4 times amplification, which is plus 12 dB. And I quite like it this way. But if you really need this knob just to attenuate, then you can make it happen. Let's retune this triangle because it's, well, it's getting a little bit annoying. When we ignore the bottom half of ARKAN, you can see that there's 3 more controls that we haven't used. Now let's first look at this switch here. This is an inversion switch, and this inverts whatever is coming into the input, which you can see here. So the green trace is what I'm sending in, and the red trace is what's coming out. So you can invert, clip, and gain stage your signal. There's no separate CV control over this switch here. Then there's this bias input and bias attenuator. When there's nothing patched in here, and you turn it to the right, well, or to the left, you add an offset. And if you take into account that 1 square on data stands for 5 volts, then you can see that I'm adding about 5 volts of offset to the signal. Alternatively, turning it to the left adds an offset of minus 5 volts. And you can see that at its edges, again, we can see some clipping of our wave. This is even more so when I turn up the amplification at the input stage. And the thing we are seeing right here is asymmetrical clipping. Now at this moment this knob is adding or subtracting 5 volts, but you can set this on the back of the unit to add or subtract 10 volts. Which would give us 10 volts of positive or negative offset and, well, even more asymmetrical clipping. You can control the offset with CV, so let's first show you that. Now I'm sending in a triangle LFO and nothing is happening. This is because as soon as you patch something in here, this little knob becomes an attenuator for this signal. Let's turn it to the right. And now you can see that the red trace, which is the output of ARKAN, is being shifted up and down. By the way, these LED cables, at least the ones I have, they light up green when the signal is positive and they light up red when the signal is negative. Keep in mind that these also drain a little bit of your voltage, but I think for this presentation that's not a problem. And of course turning it to the left inverts the effect of what we are sending in, which means that a positive voltage would cause a negative offset. And of course you can scale this if you set this knob anywhere besides the extremes or at the center. Like that. Now you can also hear that this doesn't change the sound even when I turn up the speed. Well, if you're using a headphone or good speakers, at this point you might be starting to hear an extra frequency being added to the sound. And what we're doing here is actually just mixing in a second VCO, or when you slow it down, you're kind of mixing in a second LFO, and this is causing the offset to happen. Let's switch this LFO to audio rates briefly. So here you can hear that I'm just mixing in a second VCO. Okay, let's get it to move slow again. Well, in fact, let's remove this. Now let's use this slow moving triangle LFO, which is bipolar by the way, to modulate this parameter. And again, nothing is happening. Well, that's because as soon as you send a signal in to the CV input here, the operation of this attenuator kind of inverts to, well, what you would expect, being completely closed when it's to the left and completely open when it's to the right. And now we are seeing 4-quadrant multiplier. Now we're seeing a 4-quadrant multiplier in action, which is just ring modulation. And the difference between a ring modulator and a regular VCA is simply the fact that it reacts to negative CVs here. On a regular 2-quadrant multiplier, the sound wouldn't get through when you're sending in negative CV. And that's probably mainly because most VCAs are just, well, conceptualized to be used with an envelope which is usually positive. So there's no need for the circuit to react to negative voltages, but if you want to be able to do stuff like this, you need a 4-quadrant multiplier, aka a ring modulator. And you can see what's happening here. When the voltage going in is positive, the wave just gets attenuated, and when the voltage that we're sending in is negative, the wave is getting, well, also attenuated but inverted at the same time. So when I now turn up the rate of this LFO, you can hear the ring modulation at audio rates. Of course, we can still do some clipping and gain staging. We can still add offset for that asymmetrical clipping. And it all gets mangled by the VCO that I'm sending in here. And you can create wonderful tones with this. Okay, let's remove the offset. Let's turn this back to close to unity gain. Let's switch this modulator back to LFO rates. Now the one knob that we haven't talked about, and it's this one that's really unique to ARKAN, and this can greatly influence the behavior of ARKAN. So let me turn this knob to the left and we will be able to see and hear the difference. And I think you can hear it. There's this change to the rhythm of the sound. And this is because, well, the rising voltage that we are sending in is controlling the amplitude in a linear way, at least when this knob is to the right. But when we turn it to the left, we get this response to be more curved, more exponential. And what this means in practice is that lower voltages will have far less effect on the output than higher voltages. And the higher they go up, the higher the effect is. And this can create these, well, this kind of behavior. Now there's a little bit of a difference between this swoop and the other one. This is just because, well, the wave I'm sending in is not perfectly centered around zero. It's something with these LED cables that changes the signal a little bit. This might be not so interesting, but as soon as I crank up the rate of the modulator here, and by the way, modulator, when we're talking about a 4-quadrant multiplier or ring modulation, it's really not the right word. In ring modulation, there's no carrier or modulator. It's just two signals that get ring modulated by each other. But of course, it's easier to look at the signal at the input as the carrier and the signal we're sending into the CV input as the modulator. And if we would be talking about a regular VCA, a 2-quadrant multiplier, this would be the correct terminology. But in a ring modulator or 4-quadrant multiplier, these two signals are really rather equal. So now we are ring modulating two triangle waves, and you'll hear when I turn this curvature knob to the left now, the change to the sound will be apparent. And you can hear that this gets a lot more spiky. Let's turn up the frequencies here. Turning it to the right gives us a softer response. Turning it to the left gives us that spiky stuff. Don't forget, you can still amplify this signal. You can still offset the signal. And as you can hear, this gives us a lot of control over the shape of our sound. I'm just playing around with the relative pitches of the two signals here. You can also turn down the effect of the second signal to bring back our original wave, which is of course being amplified and offsetted as well. Now it's always cool to have two VCA channels because, well, while I'm recording this, I realized that I would want to control the turning of this knob with CV to bring in these harmonics with, for example, an LFO. And we can do this. Now let me quickly patch this up. So what I'll do is run this LFO, well, it's VCO at this point, through the second channel of ARKAN, and I'll use an envelope to open and close the VCA on the bottom, and then I'll use the output of the bottom half to control this. So let's make, well, I'll just use a looping envelope to demonstrate my point here. And then of course I need to turn this to the right. So now you can hear, well, and see that I'm sending in a VCO here. I'm attenuating that signal by sending an envelope into the CV input. This opens and closes this VCO, and I'm sending that signal into the top half CV input here. So this signal is now ring modulating the triangle that we are sending in with the green cable. Additionally, you can send in another signal, well, you can send in two more, but let's just send in a third triangle wave to the bias input of the top half here. So this will control the asymmetrical clipping. So as you can hear, you can create cool sounds from just triangle waves. Now this is very harsh. Maybe I should turn this down a bit. Let me quickly add in some reverb and delay. Is it even connected? Yes, it is. And this is just lovely. Let me try to patch a quick sequence to this patch. I can also send this pitch sequence to all 3 VCOs that I'm using. Let's try that one as well. So now I changed my 3 VCOs to be pitched at perfect ratios of each other. I'm using 3 bodies. So to make this happen, I just need to flick 2 switches and we are getting exact ratios. And when you start ring modulating and mixing VCOs together that are at perfect ratios of each other, you can get these kind of, well, a little bit cleaner ring modulation sound. Which I think is very lovely. Let's increase the speed of the sequence. And you can hear that, well, there's a wide range of sounds to explore with even just this simple patch. For example, by offsetting the modulator, you can create more changes. So let's patch in a quick LFO here. Well, I'll use an output of orbit 3, which is kind of a slow, chaotic movement. Let's turn down the outboard effects. If I turn up the rate of orbit 3 that I'm sending in here, you can hear its effect more clear. But when we turn this down, well, I mean, slow it down, it becomes more subtle. Well, I really like how this is sounding. Well, let's bring the delay and the reverb back. It's just too lovely not to. Sometimes a patch doesn't need to be very complex. As long as there is constant movement to the sound, it can be very lovely to listen to. And of course, that's where you need a utility module like ARKAN that you can use to, well, offset, attenuate, clip, mix your signals. Either your modulators or your sound itself. I'll remove all this cable mess here, and I'll just walk you through two of the examples that are written down in the manual of ARKAN, which is, well, kudos to Daniel of Malstrom. Those manuals are really great. And they're not only great from a content perspective, the graphical design in them is also, well, very nice if you care for things like that. Besides using ARKAN as a ring modulator, you can also just use it as a 2-quadrant multiplier. Let's crank up the resonance on filter 8 here, so we get this sine wave. And I've just routed it through, just like before, the top half of ARKAN. Green line is the signal that I'm sending in, so the sine wave from filter 8. The red trace is what's coming out. And now I will use the yellow trace to send an envelope through. Once again, I'm just going to use a cycling envelope. So this is a strictly positive envelope that I will now be using. And if we now send this to the CV input on ARKAN, at first there's nothing happening because the effect of this CV input is turned completely down, which means that the signal is getting through. But as I turn it up, the effect of this CV input, which is now just receiving an envelope, can be heard. Now sometimes VCAs don't completely go silent, but by turning this curvature knob to the left, you get a spikier response, which also means that you will get that silence between the notes. Let me turn down my mixer channel here. Now, besides using ARKAN as a regular VCA, you can just use it as kind of a voltage tool. Just as I showed you before, you can use the offset to create a positive signal out of the bipolar one. You can make it unipolar negative as well. You can invert it. You can clip it, and you can scale it. And these are things that can be really useful, especially when you start interfacing modules with each other from different makers. Some modules expect positive CV signals for modulation. Others really want bipolar signals. Well, you can do all of those conversions with ARKAN. Another thing that you can use ARKAN for, which is outside of the regular VCA realm, is using the two halves linked to each other. So I'll use this white cable to chain the output of the top half, which is still receiving the sine wave, to the input of the bottom half. And then you can start doing all kinds of clipping and offsetting. And inverting. And at this point, ARKAN just becomes voltage controlled clipper. Let's send in that envelope again to, well, modulate, for example, the offset of the bottom half. Maybe the volume of the first half. Or the volume of the second half. Let's turn up to audio rates this modulator. So that can give you all kinds of nasty goodness. Another thing that's shown in the manual is how you can use ARKAN as, well, a voltage controlled harmonics shifter. No, I should say octave switcher. For this you need, well, some kind of multiple. I'll just use a stackable patch cable for this. So what you want to do for this is send in a signal, preferably a triangle or a sine wave. You send in a signal to the signal input and you mult that signal. And you send it to the CV input as well. And you can see by turning up this signal, you fold the wave in on itself. And you get this sound that's one octave higher. Turning the curvature knob, creates different variations. And then if you do what I did earlier, use the bottom half of ARKAN to modulate the level of this multed signal. Well, let me show you. course, you can still go ahead and clip everything to pieces. Mind you, this is just using sine waves. And you can also, well, invert these, which creates even more variations. Now I'm really curious how this will sound like with a triangle wave. So let's just quickly do that. Now that's a type of wave that you don't see very often on a scope. Yeah, it's really cool. And well, now we're here. Let's just send in a saw wave as well. Oh wow. Okay, and to finish things off, let's try a square wave. It's probably not the ideal patch to be using a square wave for. Now one last thing before I finish the video. You can use ARKAN as a 2-channel and even 4-channel mixer if you want. Let me quickly show you this. So I'm sending in this triangle wave coming from 3-body, a skill, reverb and a delay. It's just going through the top channel of ARKAN. And as I showed you before, you can amplify it or attenuate it. You can control the output of volume with this knob. Now, when nothing is connected to this output, the signal we're sending on the top here will be present at the bottom output as well. And it doesn't matter what the settings on the bottom channel are. The output of this one just gets mixed with that one. So if I then send in a second wave, well, let's try a saw wave. So if I send in a second signal into the input of the bottom half here, this gets mixed in. And we can control the level and the amplification of this second wave with the bottom half of ARKAN. So you can control the relative levels of these two waves just by using these knobs. Keep in mind that when nothing is connected here, the direction of these knobs is inverted, so turning it to the left is fully open. Now you can send in more signals. Let's take a square wave. So you can send in 2 more signals to the bias inputs, because this is essentially just getting mixed with the top channel here. And you can set the volume and even the inversion with this bias attenuator. And since there's another one of those here, you can mix in a 4th signal. I know I said one more thing, but I just thought of another thing that I really want to show you. You can use these curvature controls to change the shape of a wave. It's not something that you would expect to be able to do with a VCA. So I already showed you that this CV input controls the amplitude or inversion of whatever we are sending in here. So when we send a signal into the CV input, and nothing into the signal input, you would indeed expect that you don't get any signal from the output here. Let's route this through. So I'm sending this triangle into the CV input, not into the signal input. And we're not getting anything out of the output on ARKAN. It doesn't matter how you turn this knob. There's just no signal for this CV to process. But if you remember that this bias knob here affects the input circuit, then you might already know what's going to happen when I turn this one to the right or the left. And then if I open this one, you can see that now we are amplitude or ring modulating these 5 volts here. And this gives us a perfect copy of the wave we are sending in. If we switch this to invert, nothing happens. If you want to invert the wave, you need to turn this one to -5 volts of offset. Now let's keep things a little bit more simple and turn it to the right. You can still control the amplitude here. But what you can do as well when you use ARKAN like this is change the shape of your wave by changing the curvature here. And this is really cool. So just by sending in a basic triangle, you get this. And I think that's a really cool feature. You can try this with regular VCAs as well, but then you don't have the built-in 5 volts of offset. Well, 5 volts, you can choose how many volts you want. And this is really cool. And then of course you can go and combine all of these tricks to creating wonderful things. So that's going to be it for this video about ARKAN by Malstrom. ARKAN is a really clever utility tool. It's not just a VCA. It's not just a ring modulator. It's also not just a mixer or an attenuator offset module. It can do all kinds of cool things. And I hope that I was able to get that across at least a little bit. And by the way, thanks to Malstrom for sending me this unit to figure out how it works and to make a video about it. I'm also really enjoying Mandrake by Malstrom as a kick drum. It's really versatile, and I made a video about it. Well, I made a video where it's featured. I link that in the description box if you're curious about Mandrake as well. So without much further ado, I hope you learned something. Thank you very much for watching, and I see you next time. Bye.